Hello everyone. In this video we are going to cover operator overloading, and more specifically for this class we are going to overload the equals operator and the plus operator. So how does operator overloading work and what is it? Well, operator overloading is adding additional functionality to operators that we use. For example, we use the plus operator, the minus, multiply, multiply, division, modulus, and so on, equals, double equals, not equals, right, and so on. And they all mean something when it comes to interacting with numbers and strings and such. And when we create our own classes, we have the option of defining our own behavior. And usually it's good to define your own behavior on how these operators work. So how do we go about overloading these operators? Well, first, I'm going to overload the equals operator. So with that, I'm going to return a shape 2D, and I'm going to say operator equals. Okay, so now I'm defining which operator I'm overloading, which is the equal sign. What am I going to get as an input? Well, I'm going to have it kind of like the copy constructor. I'm going to get a const shape 2D reference, right? And I'm going to call this input shape. And I do this to save memory by getting a reference to the class. And because it's a reference, there's a possibility that I might accidentally overwrite data here, so I make it constant, so that way I can get a reference to the shape, which saves me memory, but I keep it constant so that I don't accidentally modify any of the values here. So why don't we go about implementing the equals operator overloading. So we will type out the return data type, and we'll have to specify that this operator that we're overloading is belonging to shape 2D. Right, so here I'm telling the computer that, hey, this equals operator that I'm overloading is going to belong to the shape 2D class. Right, so we'll have our input, which is const shape 2D, and we'll have a reference to the shape. So what is this going to look like? Well, here's how I like to think about it. We're going to have the left hand side equals the right hand side. Okay, the right hand side is equal to shape. And by shape here, I mean this shape. So what is the left-hand side? The left-hand side is going to be the internal variables of this class. So I will say that length is equal to shape dot get length. Width is equal to shape dot get width. However, I need an output, which is going to be a shape 2D class. Well, I'm going to return this. And the this keyword is an important keyword. What we're returning here, when I say we're returning this, is we are returning the class that's calling this operator. Right? So we're not creating a temporary class to store these values, nor are we returning the right hand side's shape. We're returning the class itself that's on the left hand side that calls this back to itself. It's a little bit weird, but this is best practices on how to implement the equals operator. Some might put a reference here. You might return a reference, right? And to reflect that in the header file, it would look like this. And we can do that, and we will do that for this example. However, you can see implementations like this. Right, the difference is that the top operator that's being overloaded is returning a reference to itself, and on the line below it is not. It's returning a copy of itself. But for all intents and purposes, we are going to return a reference to itself, which is this. And something to keep in mind when you implement this operator is you have to be able to set it equal to itself. Right, and that's a tricky problem because a lot of people, when they think about setting the equals, when they're overloading the equals operator, they just want to copy stuff over, or if it's a dynamically allocated data, you might delete stuff. You might delete internal variable before copying the right hand side variables. But if it's the same variable, you're gonna destroy your own internal attributes for your class, right? But if you're copying it to yourself, you're not going to be able to copy it to yourself because you destroy your own data before you copy it. Right, so things like that can get tricky, and when it comes to overloading the equals operator, you need to be very careful and try to think out the logic in the best, most thorough way you can. Because, the equals operator needs to withstand two tests. It should be able to take another class of its same class type and equate it to itself, and it should be able to equate the class to its own self. And with that out of the way and those things considered, you have a successful overloading of the equals operator. Now, what comes next? Well, here I want to play with some arithmetic, and for this video, in order to keep it short, we're going to just overload the plus operator, and we will have the same inputs. And we will get a reference for it. Again, to save memory, and we make it constant so that we don't accidentally edit something that we may not want to. So how we go about this? Well, what's interesting about overloading operators is that you get to define how you get to interact with the plus operator. Right, that's what's really nice. So you get to define how you get to define the behavior between these classes. Right, and if I wanted to, for example, I can say, I don't know, I can create a temporary shape 2D temp. I will say set temp dot set length is going to be equal to get length plus shape dot get length. And I can do the same thing for width. Set width, which is going to be get width from our internal variable plus shape dot get width. And then here we're going to return temp. Right, so this is one way of defining the behavior. If I wanted to, I could have it set to its own internal variables, and actually for this, I should do it that way. Set length. We'll do that here. Set width. And we'll do that here. Right, and here's one way of doing that, and I can use the same approach here, but here I opted to create a temporary class just called temp. And I like to do that because when we're doing something like A is equal to B plus C, I assume that they're all different and independent. So I'd like to assume that the contents of C and the contents of B remain unchanged as we copy this data and load it onto A. So that's why I use a temporary variable. But you are more than welcome to use this type of methodology when we set the internal variables and return this. Right, it's up to you to define that behavior. And with that, here's a quick introduction to overloading operators. So one last thing to do is to test. So we will say shape 2D. I will say fourth shape is equal to my second shape. And then I will say my third shape is equal to fourth shape plus my second shape. So if I wanted to see the output of both fourth shape and my third shape, I'd have to set up something like this where I have to call the getters. Here, I'm lazy. I like to have some way of printing just my class out. It'd be really great if I can do something like this. Right, this feels more intuitive because this is how we print our other variables. And in the next video, we'll talk about overloading the double angle bracket operator in both directions. And this is actually special, and this is not going to be exactly a method, but its own independent function. And more specifically, it will be a friend function. Thanks for watching.